this is not a healthy fixation, partly because they're inanimate objects and can't reciprocate those feelings, but also partly because it's often a waste of our time, our energy, and our resources. And I've been feeling this for a long time. This is not new. If you've watched some of my other talks in the past, I've been using the cloud for quite a long time. I think since 2008, I've been using public cloud. And while I know I understand that in certain narrow circumstances, having your own infrastructure may make sense, I actually think for most of you, it's probably a bad idea. And in this talk today, I'm going to push this idea even further and saying that maybe you should be pushing even more of your work onto the cloud. So let's kick this off. So, bit of background, very brief background. I wrote a book about microservices. I'm writing a second edition of this book. It should be out in the middle of next year. We're aiming for June, July 2021. There's an early access version of this book available. There's information about that over on my website. I also released a second book towards the end of last year. That book was Monolith to Microservices. And this was really a book which was a deep dive looking into the aspects of sort of how you take an existing monolithic architecture or maybe just a service that's got too big and how you break that apart. So there's lots of detail there about kind of migration patterns, how you pull data apart, how you deal with consistency and all this sort of kind of stuff. So if you're going through that process, give that book a read. I'm sure it'll be useful to you. There are links on my website to how you can get hold of these books if you are otherwise able to find them on the Googles. The talk today is really split into three parts. The first is we're going to give a little bit of an overview of where we are with the public cloud and private infrastructure. So kind of talking very briefly in terms of, what's going on in this particular landscape. I'm actually just going to very, very quickly, this is on the fly shifting. Am I going to need to do this? No, I'm good. Yes, I'm just double checking I had the right slides unskipped. And then we're going to talk a little bit specifically about serverless. What is serverless? Why is it interesting to us? How might it help us? And then we're going to talk about serverless in the context of microservices, because microservices are kind of my thing. And I'm always interested in things that might make microservices either slightly less dangerous or slightly less complicated. And serverless may not make them less dangerous, but it might make them a little bit easier to work with. So we'll see. But we're going to start off by talking really about the kind of space we're in when it comes to private infrastructure and our kind of approach to the cloud. This is in terms of thinking about us as an industry as a whole. And despite this kind of idea that everyone's rushing to public cloud, it's not actually really the case, or at least that pace of change has kind of plateaued somewhat. We are clearly still very much in love with our own infrastructure. So there's a company called IDC, and they sort of track infrastructure spend and sort of where that proportion of our infrastructure spend goes on more or less on a quarterly basis. I'm not exactly sure how they get their numbers, but their numbers back up my argument, so I'm going to be using them. So what we're seeing here on this chart is a percentage of spend. That's the 100% of the spend in each of these columns. And we're seeing that broken down in terms of, so the top little bit there, let me get my stylus out and I can show you. So the top little bit here, this represents public cloud. We've then got private cloud. And then down here, we've kind of got your traditional data center spend. Now, to my mind, the first thing that jumps out at me is I've got no idea how you distinguish between private cloud spend and traditional data center spend. And given that the vast majority of the private clouds I've worked with have been unbelievably terrible, I would say you could probably really lump them all in together. But by the by, really when we look at this particular graph, this area here, that is spend in on-prem infrastructure, be it private cloud or your own infrastructure. So, if we look, say, at the stats just for where we are quite now in 2020, 65% of all spend is on-prem. Okay, and so the remaining sort of 35% of that is private, is sort of public cloud. But the really interesting thing is not just what that number is now, but the fact that that's really plateaued for the last 3 years. There's not been much movement. And of course, another thing that's interesting is we are spending more money in total year on year on infrastructure in general. So, we're still spending by far the big, although this whole pie is growing, the actual kind of proportion of public cloud has been pretty stable for a while now. If If you look what's happening forward, and IDC forecasts forward as well, those forecasts are always off to some extent, but it is at least interesting. At least if they're consistently off, we can still use them a little bit, right? But what they're forecasting is that growth on private cloud is going to grow about 9.2% over the next 5 years. That's compound growth. During the same period, they only expect public cloud to grow at about 6%. So, yes, public cloud is growing, but private cloud is, but not as fast as private cloud. So, that's where a lot more money and spend is going. And I'm sure if you've ever sort of seen, Red Hat consultants running around installing OpenShift clusters at your place of work, where a lot of that money is going as well. And the problem I have with this is, I like computers. I've got lots of infrastructure knocking around. I've got a laptop here. I've got an iPad. I've got my iMac. I've got a Windows gaming machine, a very old Windows gaming machine, it must be said, under my desk. No Valhalla for me. But, I love the kit. I've got a server room in my attic. No one needs a server room in their attic, but I can justify having one as a hobbyist, right? But I don't really need it. Anything that I do that's useful, I do on the cloud, in terms of running infrastructure. No one actually pays me to do that anymore. But we kind of trapped, right? And I think that we're in this danger that we've acquired all this infrastructure, and now we are working for the infrastructure rather than the infrastructure working for us. If we think about a potted history of infrastructure as a whole, right? For many, many, many years, if you ran infrastructure, everything was done directly onto physical infrastructure. And then around the early sort of 2000s, this is when virtualization really started to kick into high gear. So on your normal kind of data center, you had lots of these boxes that you built, you purchased, you've got software running on it, and you would always overbuy the hardware, right? Because it takes so long to get a machine in. It might take you 3 to 6 months to get a server in. So you'd always buy it for more than what you thought you needed. So you'd oversize just in case you got it wrong. And that meant that often the utilization of data centers was extremely poor. I remember when I started at ThoughtWorks back in around 2004, 2005, I saw some stats that showed that the average data center utilization was around 20%. That meant you had 80% of most companies' data centers were sitting there idle. Virtualization had a huge impact in that space, though. With virtualization, you can take a physical machine and break it down into virtual machines. And those virtual machines then allow you to get a much better utilization of your infrastructure. And, to be blatantly honest, virtualization, pretty awesome. I still stand by that. I think it's pretty awesome. It's kind of interesting, although AWS, for example, as a public cloud vendor, started in 2006, it really only started really getting traction when they started providing publicly hosted virtualized primitives. Think of things like EC2, S3, so data storage networking. And so at this point, the world was already primed to accept the concept of virtualization. So then all we needed to do for AWS was be happy for somebody else to run those virtualized primitives. Now, what happened, of course, is that AWS showed what was possible when you took a virtualized infrastructure and stuck a decent API on top. Now we had the full power of automation and theoretically developer-friendly automation, although in reality, not really. But nonetheless, you could automate everything. And that was fantastic. It was in that space we saw OpenStack came around in the early 2010s. So this was a project originally a collaboration between Rackspace and NASA. NASA had some very specific needs around how they managed their own computers. And look, if you're NASA, you get to have your own servers. That's fine. But they wanted a software management platform, a control plane, if you will, for their infrastructure to be able to use them effectively. And they absolutely took inspiration from what AWS had done. And so they tried creating sort of virtualized software primitives around network storage and compute. And OpenStack was the promise of OpenStack for enterprise organizations all around the world was that this was now going to give you AWS on-prem. Right, that's what the promise was. You don't need to worry about running EC2 instances on some bookseller's machines, and that was often the pushback you got early to 2010. Why would I let a bookseller run my servers? No. I'll get OpenStack in, and that will solve my problem. And look, don't get me wrong, there has been some amazing work done around OpenStack. It was the world's largest open source project for quite a while. There's been some niche situations where it's been incredibly successful. I think a bunch of the big China cloud providers basically built on top of OpenStack, for example. But in terms of it transforming the private cloud experience or giving us anything like a decent private cloud experience, I wonder how many of you are actively working on an OpenStack based system day in, day out. Very few of you are, right? Most of this was money down the drain. And, you know, so we didn't really get the returns on that we maybe did get from virtualization. And then what's now been happening, of course, is we're saying, well, you know, for some people that might have been a sign to maybe look at public cloud, and, you know, public cloud growth did kick in the 2010s. That was its kind of prime growth years, right? But now, of course, it's okay, because you don't have to believe that you can't run your own infrastructure anymore, because we've got the thing that's going to solve all your problems. Don't worry. We've got Kubernetes. So Kubernetes is basically the OpenStack of the 2020s, right? It's going to solve all your problems. It's going to allow you to have your own infrastructure, and it's going to solve all of these issues. Now, to be fair to the people who actually build Kubernetes, that's not a promise they're making. But it's absolutely a promise that the people packaging Kubernetes are making. Don't worry about public cloud. We'll build you a Kubernetes cluster, and it will be great. Look, I do worry with Kubernetes, and it's not Kubernetes' fault, to be fair, but it is allowing us to indulge in a bit of sunk cost fallacy, right? We've been building our own data centers for years, throwing good money after bad. OpenStack didn't work out. We've got our own half-assed PaaS implementations haven't worked out, but don't worry, this time it will work out, and we're throwing good money after bad. Let's look at the anatomy of, say, a modern Kubernetes stack, and think about what happens when you're running all of it. We start off with the underlying hardware, your underlying hardware that you are managing. And on top of that, we've got an operating system, your operating system that you are patching. Then you've got the hypervisor. That's the visor that hypers visorly. And that is your hypervisor that you are patching and maintaining. On top of that, you've now got a virtual machine operating system that's running inside the VM. Guess what? That needs patching as well and managing. Then you've got your kind of container management layers where Kubernetes would sit. So now you're containerizing inside your virtual machine. And then you've got the operating system of the container. And that's a third operating system now. Guess what? That's right. It's yours. And you've got to manage patching that as well. And then on top of that, you finally get your little application. Look at the little application. Isn't that cute? Oh, they're sitting at the top of the stack. Yours now. All of this is yours. It's all your fault. This is yours now. Look at your lovely cloud native stack, right? When you run a private cloud, your organization owns all of that stuff. Now, I'm not saying it's still not a good idea, maybe in your niche situations, but let's consider something for a minute. There is a good possibility that you're not as good as running a data center as Google, Amazon, or Microsoft. I know this might be a controversial statement, but just think, you probably aren't as good as them at doing this. And you know what? You shouldn't be offended by that. You would hope they would be better at this, because they, you know, I would imagine that those three companies probably spend more money on hardware than most of your organizations are valued in a year basis, right? They do stuff at massive scale because they can afford to do that. And therefore they should be better at it, because this is what they try and do as part of their public cloud services. Unless you're also working for a public cloud vendor, that's not what you're trying to do as a company. Your focus is on building a great bank or doing a great e-commerce company, or being, getting marketing analytics people, or doing journal publishing, whatever it is. That's your focus. Your focus isn't on being awesome at running data centers and all the associated infrastructure of a modern deployment topology. That's not your focus. Your focus really is just a little tippy top. It's the application. That should be it. But you end up having to deal with all the layers underneath. Now, of course, we have the opportunity to offload a bunch of this work. So if we go back to a sort of slightly a more complex version of our stack here, we can think about these bottom layers. So we could go to a public cloud vendor and just make use of their managed virtual machine. So using EC2, for example, on AWS. And so this is where we're kind of talking about infrastructure as a service type abstractions. We could offload this bunch of the stack. Already we're in a better place. So now maybe we're still managing our own Kubernetes cluster or our own OpenShift cluster, but now it's on somebody else's managed virtual machines. And you've probably now got a lot more flexibility. You've also offloaded an awful lot of work to the vendor, right? When the Spectre and Meltdown and bugs came out, when we had to patch all those Intel chips and things, we had these massive patch rollouts that organizations were doing. I bet you there's a bunch of you still haven't had your Intel chipsets patched after those bugs came out. But I can guarantee that all of the cloud vendors did. Within 7 days, those patches got rolled out, right? They can do things like this because that's what they do it without you even have to be involved. So already we've offloaded a bunch of work. We can go further, of course, because all of the big cloud providers now offer a fully managed Kubernetes platform. So if you really do want to build on top of a Kubernetes platform, there are other choices out there, by the way, but if you really do want to, and I understand why, it's a fantastic ecosystem around it, why not run a managed Kubernetes cluster on a public cloud provider? Great. Now, all you're having to focus on is just maybe your container operating system and your application. So straight away, your worldview becomes simpler, your focus becomes simpler, and we're offloading work to somebody else. And this is still the thing that people are very bad at judging the value of. We also get trapped in this kind of like weird situation where people say, but Sam, I have to have a private cloud. I say, why? It's because I've got machines and I need to use them. Okay, but then why are you buying more machines? Well, because the machines I've got are going to be end of life. And now I've got a private cloud. I need to replace those machines. And it's like, no. If you're using those machines, it's because you've got them. Cool. But just actually have a program of getting rid of them. You don't need to do this stuff anymore. So let's move on to serverless. Now, serverless to use its full name, #serverless. So #serverless, of course, is a buzzword compliant phrase that's been around for a while. It's really only kicked into high gear in the last sort of 4 years or so, though. But as a term, it's been around since 2012. Fundamentally, a serverless offering is something which abstracts away the notion of the underlying machine. So when you work with a serverless product, you don't even have to worry or think about the machines behind the scenes. That's handled for you by the service provider. When we look at what kind of constitutes something being serverless, there's a few different ways of categorizing it. But these are kind of the key properties I come back to time and again. The first thing is you're not doing server management. You're not saying I want 10 of these or 5 of these, or I want these many CPUs, or I want this much IO. No, you don't need to engage in that. The auto scaling of these service offerings is done entirely based on how you use it. You don't say, I want more of these things. You just use it more and it will automatically scale up or automatically scale down. You also should expect from the service itself, and implicitly, you should expect it to be highly available. So you make assumptions that the robustness of the service is being handled by the service provider. So at least then you can focus your concerns around the robustness of your application on what you control. And kind of coming back to this idea of it scales up and scales down based on your use, you also should only be paying for what you use. And obviously this concept gets a little bit more fuzzy if you're running a service on-prem offering, although they don't really exist that well in the moment. So examples of serverless offerings include function as a service. Many people kind of conflate function as a service and serverless. Function as a service is a type of serverless product. There are other types of serverless products. In fact, many of them predate FAST by many years. The first sort of well-known function as a service offering was AWS Lambda, launched in 2014. The term serverless had been around for 2 years before that, in 2012. There are lots of messaging solutions that fit this bill. Think of things like Amazon SQS. The simple queue service. Guess when that was released? That's right. That was AWS's first ever product, released in 2006. The very first thing that AWS launched was a serverless point-to-point queue system, fully managed. We now have database solutions out here, and they get a bit weird because they're a bit different to the other things we've worked with. Think of things like Cosmos and DynamoDB, but we've also got things like Aurora and the like, and storage. AWS's second ever product that they launched was AWS S3. Brilliant product, fantastic product, right? Talk about implicit high availability. You get 4 nines availability out of the box and 11 nines durability. Okay, I don't have to spin up machines for that. I just throw data and I'm charged on what I use. This is a pure serverless product offering. AWS's focus initially, this was kind of interesting to me. This is where they started. They focused initially on primitives that are more developer friendly, SQS and S3. They made their market share, though, in terms of infrastructure as a service offerings, and that's still where the bulk of their money goes. If any of you follow Quinny Pig on Twitter, he's basically a cloud economist. His newsletter is hilarious, by the way. But he works with clients to optimize their AWS bills. And he basically says, look, on average, 70% of all people's AWS bills is still EC2 instances, right? That's still the bulk of where AWS makes their money. This for me is a little bit like AOL still making most of their profits from dial-up. But anyway, you've got to make money any way you can. Now, function as a service gets a lot of our attention here. And from a developer-friendly point of view, there's a reason why. If we come back to our stack diagram, what FAS allows us to do is now even ignore the fact that containers are even a thing. I actually don't think Kubernetes is very developer friendly. It's not designed for that purpose, but often we expect developers to be able to code to it. And I think that's kind of daft, right? Kubernetes is basically just a way to manage container workloads. Kubernetes will vanish beneath a layer of abstractions over time. It's already happening. And you're probably building your own abstractions if you're using Kubernetes. The nice thing about function as a service is it's like, don't worry about the deployment side of things. Give us your code. Tell us when you want it to just deploy it. Tell us what you want to trigger it, and we'll handle the rest. So even more of that stack is now somebody else's problem. And you're hiding more detail. You're working at a high level of abstraction and hopefully getting more done as a result. If we think about this is all really about abstractions, right? We start off with physical infrastructure, which is what you used to have to manage, and then we virtualized it. We kind of have the big three primitives of infrastructure as a service, in terms of compute, networking, and storage. And, the public cloud providers then started providing higher level service offerings. We get things like a managed database like RDS or managed SQL on Azure. So you're still paying for kind of physical compute units. You're still scaling your spend based on the size of the machines and the number of machines that's running those clusters, but they're managing more of the details for us. Likewise, when you spin up, say, EKS, so a container orchestration as a service solution, for example, you're going to pay for the size of the EC2 instances that your EKS cluster's running on. And they don't actually charge you really for the Kubernetes side of things. They're just charging you really for the EC2 spend under the hood. And then we've got a high level of abstraction. Again, this is where serverless fits in. And arguably what serverless is are developer-friendly computing primitives that we can swap in and swap out. So we can take a function workload, we can do backend as a service, we can do messaging. If we don't like these serverless products, we could just throw it out and do it ourselves directly if we want to. So we can kind of mix and match these offerings. That's nice. One of the dangers when you create abstractions is you abstract too far. And then when you really need to get to the low level detail, you can't. But you can. On all the public cloud, you can have your cake and eat it. If FAS isn't working for you, you can still spin up an EC2 instance and do it all yourself if you want to. And there's still kind of people trying to build platforms as a service, which are kind of more, we do everything for you. And we've been trying as an industry for like about 15 years to create good platform as experience solution, good PaaS experiences for our developers. And we keep getting those abstraction levels wrong. But serverless for me is the right level of abstraction, partly because you can mix and match. You can pull in the bits you need to assemble what you need. And if it doesn't work for you, you can swap it out and pick something else instead. As you go up these kind of levels of abstraction, you're dealing with less infrastructure overhead, right? You're more of this stuff is hidden from you. So you don't have to worry about the details. And so ideally, you're going to engage with this stack as high up as you can go. PaaS, I don't think really is a viable option for most people, but the server stuff absolutely is. As you come down this abstraction stack, though, you're going to have much more control over the lower level settings and configuration, right? So much more control as you come down the stack. Guess what comes with control? That's right, responsibility. Or I think that might be what happens when you get bitten by a spider or something. But you're now got a lot more work that you've got to do. But that might be worth it to you if you need that level of control. We should probably talk briefly about function as a service because this is the one that gets the most attention. And I totally understand why. So for those of you who haven't used FAS, the way it works conceptually is quite simple. You take some code, you give it to the FAS platform and say, when this happens, run this code. That's kind of it, really. So you take your code, your function, your unit of deployment, which is the function, this will be launched automatically when some kind of triggering action occurs. And you specify what triggering action is going to launch your function. But this could be an API call. It could be a message arriving. It could be a file being sent. It could be some kind of time-based mechanism. So effectively, this is a great way of kind of implementing a bit more of a robust cron type solution. So this function will get launched automatically when one of those trigger things is built. The only control you really have around this invocation and the nature of the invocation is that you're going to specify, say, how much memory this function is going to get. And this is as close as you get to getting any really underlying details. Additional instances of your function will automatically be spun up as required. So if you get like 15 different API calls, as new API calls come in, more functions will be launched and you'll be able to handle this. And we also will only be paying for what we use. This is it, right? So here's my code, just want it to run when these things happen. So an API call comes, spin up my function, run it, and it will shut down again automatically. If no one makes any API calls, guess what? I don't get charged. It's also kind of nice from a security point of view, right? If you don't need to be running stuff, just don't run stuff. Now, there are absolutely some limitations around fast that we should talk about. The first is that there is a time limitation on the function invocations. Those are actually pretty generous now. When Lambda first launched, these invocations may be limited to 30 seconds, which is still a lot for an API call, right? But they're now up to 30 minutes, which covers an awful lot of stuff. You do also have runtime restrictions. The underlying fast platform is handling a lot of details for you. What that basically means is it's not just your programming language, but potentially the runtime version of your choice has to be supported by the platform. So you're going to have some restrictions placed in terms of what programming languages you can use. In practice, it's not a big deal. Firstly, because there are shim solutions around for that. But secondly, because both AWS and Azure are doing a very good job of rolling out new more runtime support in this space. I would sort of say Azure is definitely doing the best out of the three in terms of broad language support. AWS is doing pretty well as well, though. You could run a Windows bat file as a function on Azure. I mean, you shouldn't, but you can. Google's really not doing very well here in this space because their cloud function stuff is really kind of lagging in terms of a broader language support. Now, the other thing is that these function invocations are stateless. So when a function runs and it's sort of processing and handling a request, when that invocation finishes, it's as though that whole runtime was shut down. And a subsequent invocation would kind of start up a brand new runtime. In reality, that's not what's happening, especially for JVM-based and CLR-based runtimes, because they're actually kept warmed up to avoid the cold start time. But you can't really maintain and persist state from one function invocation to another. You could offload that state to a database if you wanted to, but you don't really get to have stateful microservices. A caveat around that would be that Microsoft have created these things called durable functions. And durable functions are super smart. They basically work like continuations, but you can use things like that. So from within the durable function, I can actually invoke other functions using things like async awaits. And when I trigger the function invocation of the other function, the parent function is suspended. The other function executes, and when it finishes, your parent function is re-invoked, and it repopulates the state. It's a really clever way of doing it. So that's very, very, very cool. It's also the kind of thing that only Microsoft would do, right? AWS aren't really very developer focused, in my opinion. They're never going to do things that require you to build custom SDKs inside the program. Well, I'd be surprised if they would do something like this. The closest AWS get to this stuff is like step functions, which I hate step functions because it's basically like CloudFormations for code, and CloudFormation is horrendous. And I'm now going to start ranting about JSON if we go any further. Other kind of limitations is very much a minor thing. And this is that you have limited ability to control exactly how things scale up. So your limitation here is typically, I only want a max number of concurrent invocations. So this can be problematic. So I've certainly talked to people where their function part of the system spun up really, really fast and then overwhelmed other parts of their system. So having a little bit more control there would be useful. It's not a massive problem, but certainly when you get into things like sort of the message-based triggering, you need to be aware of how that scale up happens, and you may need to get into partitioning queues and things. And the other area here where you're kind of beholden to the platform is around things like observability and understanding what's going on inside your function. A lot of the kinds of things that we would often do around, say, microservice observability involve running sidecar processes or having things persistently running inside that process to get information. We can't do that now with this kind of platform. So we're having to rely on the information coming out of App Insights or CloudTrail or whatever else it is. Now, those limitations aside, and many of these limitations are being dealt with, I kind of think that FAS is the best developer-friendly abstraction we've had for deploying and managing code since Heroku. And I do not say that lightly, because Heroku is freaking awesome and is still, I think, the gold standard. I mean, there's a reason why so many people have basically just straight up tried to copy the user experience of Heroku. Which was a good reason, right? Absolutely. It's a shame they haven't been able to make a massive market out of that, out of what Heroku is. But like, no, CloudFormation got completely rebuilt to try and mimic Heroku. So this is high praise from me, really high praise from me. Fundamentally, right, I'm doing way less infrastructure work. I'm more focused on actually building my bloody software, which is what we want. Now, what about serverless on Kubernetes? Well, you kind of got options here. Now, serverless in general, you don't really have much. There aren't backend good serverless messaging solutions, right? Kafka isn't a serverless messaging solution. I'd need a full managed API for dynamically creating topics and everything else on top of that. I don't have that. So you don't really have anything really other than FAS on-prem. So you've got probably, if you wanted, say, a fast type runtime on top of your Kubernetes cluster that you're running yourself, I would probably start by taking a look at OpenFAS. Yes, there are alternatives out there, but OpenFAS has been around for a long time. It's got a great team, broad support, lots of ongoing use. So do take a look at OpenFAS. Some of you might say, but Sam, what about Knative? And I'd say, yes, I'm aware of Knative. Thank you for asking. Knative is Google's offering in this space. Now, I am warning people to be very cautious about Knative. A couple of things to be aware of. Firstly, a lot of the way in which Kubernetes became successful was the fact that Google were, by putting it into the Cloud Native Computing Foundation, well, creating the CNCF as part of the Linux Foundation to help curate Kubernetes and bring lots of people in, was the way in which Kubernetes became successful. We had many eyes helping kind of take the de-Googling it to an extent, right? Making it kind of polishing off some of the rough edges and sort of adapting its kind of use in a little way in terms of what normal people want, not people at Google. I know I've just said that people at Google aren't normal people, but I worked there for 2 years. I can say stuff like that. But you've got, but then that went really, really well. Knative, though, Google have decided we're not doing that with CNCF. We're doing it by ourselves. And Google have a terrible track record at kind of releasing production-ready software in a timely manner. They are quite happy to hype something, and you can wait years for it actually to be at the point where you'd want to use it in production. I mean, you can look at Istio as one concrete example. It took years for them to get to 1.0. And even at that point, they were still making significant changes subsequently. So I was warning people to delay their adopting Istio because of that. I still actually, in general, for service meshes, say if you can wait 6 months before adopting a service mesh, wait 6 months because the market is still maturing. Knative is going to suffer from all that and more. So it will take you a long time till it slows down. Google are very, very happy to deprecate things without warning, and breaking changes and Google go hand in hand together. So maybe in the future, but right now, if you're looking for a good fast solution on-prem, I wouldn't pick Knative unless you're very happy to be having to sort of make significant changes later on. Maybe have a look at Cloud Run from Google if that's something you're interested in, but Knative, not in the short term. Right. And I'm not ragging on Google, by the way. There's some awesome stuff. They didn't have to open source Kubernetes, although cynically this was about losing market share to Amazon, but they did. I still got friends there. They do some awesome work. Their managed VMs are brilliant. Their databases are the best, right? There's some awesome stuff that they do in that space. But just, I'm based on prior knowledge of how their open source stuff has gone. I would love to be proved wrong, but I haven't yet. Around this, at least. About many other things I've been proved wrong, but anyway. Okay, so let's talk about sort of serverless and microservices and how these things go together. Well, let's talk firstly about how we would traditionally think of deploying a microservice. Here's my microservice. This is a logical microservice. This is the shipping microservice. And normally, and typically a microservice is packaged together into a single process. But I might want multiple copies of that process. Why might I want multiple instances of that process? Well, this could be to handle more load, right? I might have more load than a single process can handle. This is also maybe allowing me to have a degree of redundancy. So if one server instance dies, I've still got additional capacity to help handle load. So we normally would have multiple instances of our microservices. So now I've got multiple processes, and the scaling model with microservices is scaling by process. Again, taking a leaf out of Heroku's book. And then our data, and we have a microservice, and we talk about microservices owning their own data. So we have their own database, right? We might have that database maybe needing some kind of replication to a read replica, or maybe to a standby, or maybe this is some kind of multi-primary setup if we're being very, very fancy. So this is fine. And then we go a bit deeper, right? Well, these nodes that we've got, we need to make sure they're distributed across different failure planes, right? In case, so we don't want all of these to be VMs running on the same machine, nor would we want all the physical machines to be in the same rack. We might not want them distributed across data centers. So on the cloud, for example, you would make sure that each of these instances is in a different availability zone. Because remember, on the public cloud, you get no SLA for a machine. You do not even get an SLA for an availability zone. You only get an SLA for compute of the region as a whole. So if we're doing this is stuff we have to consciously engage with. Even with Kubernetes, right? I say I want a certain number of these instances, and this is the distribution model I want you to use in terms of how you schedule those nodes. If I say I want 5 instances, I don't want all 5 instances to end up on the same machine. So I'm going to have to give it some information. Well, the default is a spread allocation, to be fair. But generally, when we think about that deployment, we've got to do some work in terms of thinking about how big these things are, how many of them I want, thinking about the database side of this as well. And then when these processes are running, they're just sitting there waiting for something to happen. And so we're paying money, potentially we're burning electricity, waiting for something to happen. Our deployment mechanism-wise, we're talking normally about a process. We're deploying it either onto a physical machine, a virtual machine, or a container. And, although, and from the point of view of the microservice itself, it doesn't really change much in terms of these different solutions. With a function as a service system, though, of course, how does that work? Because functions are small, right? A function, as we know, should be about 4 or 5 lines of code. And this is part of an issue, right? Because we're using the term function now in 2 different contexts. We're talking about function in the code sense of something that's small and can be self-contained. We might be talking of function in terms of the mathematical concept. We might be talking about function in the context of functional programming. But if we start, all of those still make us think about a function being teeny, teeny, tiny, like 5 or 6 lines of code. And then we start thinking, well, if I move my microservices to function as a service, I'm going to have thousands of functions, right? And it's like, no, pump the brakes. We're using the term function in a different context, right? With a fast platform, don't think about a function as a code concept. Think about it as a deployment concept, right? It's a unit of deployment is your function. So with that in mind, what would Sam suggest would be your first starting point if you wanted to take a microservice workload and deploy it onto a fast platform? It's quite straightforward. Just have one big function that implements all the functionality of your microservice. It's quite straightforward, really. Just one-to-one mapping. It's very simple. You're not massively increasing the distribution of your system. It's a service you're already familiar with. You're already running it in some other form. You could run, say, 75% of your fleet could be running normal kind of process-based deployments, and maybe 25% are running on the functions. You get a bit of comparison. Single deployable unit. And at this point, if you do nothing else, you've got a drastic reduction in the amount of infrastructure work you're worried about. This thing's going to auto-scale up. It's going to auto-scale down. Fine. I don't know why people don't just skip over this. They start going really massively fine-grained. Why? Do this. It's easy. It's really easy. Give it a go. Now, obviously, if you want to go more fine-grained, you can. So then what should you do? Well, at this point, I start thinking about, if I want to break a microservice down into smaller parts, this is what I do with normal microservice decomposition as well. I'm always kind of looking for the aggregates in my system. So aggregates are a concept from domain-driven design, but obviously they have value outside of that. But when we think about an aggregate, what we're thinking of is a collection of associated objects that you always want to treat as a single unit for the purposes of data changes. So I want to deal with it as a single transactional unit. So I don't want to split that aggregate apart, because then I'm having to manage sort of the state transition in a distributed state machine, and those things are difficult to get right. So really, we kind of want to always keep that aggregate together and use it and work with it as a single entity. And so therefore, all the code that makes changes happen to that aggregate, we also want to all be together as well, because it makes it much easier to sort of update the behavior of that in a consistent and safe manner. What that basically means is, if you decide to break your microservice down, a good starting point can be to look for aggregates. So in this example here, I might have identified 3 discrete aggregates: delivery, consignment, and route. And I might say, well, actually, I'm going to come up with effectively a function to manage each of those 3 aggregates. Now, if you decide to take a big microservice, big, right? We can talk about what big means, and break that down into smaller pieces, here's a little trick for you. Don't tell anybody. What I mean by that is it's nobody's business what you're doing inside your microservice boundary. Your external consumers should be totally unaware that you've done anything. So what you want to be able to do is to create an abstraction over your microservice such that when you break things apart, they don't notice. And how you do this will depend a little bit on the communication protocols you're using, but this should be totally transparent to external consumers. Their requests should just now transparently be routed to your delivery function. In fact, they shouldn't even be aware anything has changed at all, because what we want is the ability to change our mind without it having massive implications. This is information hiding fundamentally, right? If I break this, you could view the fact that we've decomposed this shipping microservice into smaller functions. You could view this as implementation detail. We might change our minds and merge them back together again. So if you hide that detail from the outside world, those external consumers will be blissfully unaware. As long as we maintain compatibility of that kind of higher level, coarser grained interface, that detail is hidden. Okay, so we've gone to fast. This is great. We can go further, can't we? What about a serverless database to replace our data tier? And actually, can be really beneficial. You do have this issue that, your functions start scaling up. Traditional databases can actually end up getting overwhelmed. And certainly I've spoken to a couple of people using fast platforms who have had that issue. Your data, your application tier scale quicker than your data tier can scale. So the obvious option then is to pair that with one of the serverless database products. This is where things get a little bit more tricky, despite the fact that, yes, they'll do auto scaling and durability and high availability and pay as you go for you. Yeah, that sounds great. The problem with the serverless databases is that they can be quite different to what you're used to. Like running a bit of Java code on a function versus on a process is not massively different, right? But the semantics of the database you use for the service offerings can be quite different. Cosmos and DynamoDB, as 2 examples, they look a little bit like Mongo, but they're not really like Mongo. And they're not going to be like your relational database you're used to. So you're quite probably going to have to do kind of quite a large migration effort and or change your code to potentially make use of those particular products. Now, there are exceptions. Aurora is kind of serverless-ish. And that gives you what looks like a normal relational database SQL dialect backend. So that kind of lets you kind of pretend you're still using a sort of relational database, but it happens to actually be more serverless in terms of, so there's a little bit of gray area, but that's definitely an area where you're going to have to be a bit more cautious about the database side of things. You can look at the messaging stuff. Just AWS alone has Kinesis, which is kind of their version of Kafka-ish. And they now obviously also provide a managed Kafka solution, although it's only, remember, a wire-compatible Kafka. It's not a full Kafka setup. It doesn't do all the fancy stuff that a proper Kafka cluster does. Might be good enough for you, though. So you've got Kinesis, you've got the SNS, you've got SQS. Azure has loads of awesome stuff in this space as well. And these are fully managed turnkey messaging solutions, pay as you go, not worried about spinning out machines. But again, here, the behavior can be subtly different, right? The fully managed turnkey solutions like SQS, SNS, and Kinesis, they're not exactly the same as things that you'd be used to running on-prem. When you spin up, say, the managed ActiveMQ solution, that's more like having your own ActiveMQ cluster, but it's not serverless because you're still paying for like nodes and stuff like that. Now, of course, if you're a Kubernetes fan, you don't have this either. So sorry. You're running your own message broker. Right. I've been ranting a lot and I haven't even had a beer, right? So imagine how bad this could have been. In summary, I'm thinking about this, right? What you want to be doing as a software developer, and you know this already because most of your career as a software developer is about doing this. You, at any given point in time, want to work with the highest level of abstraction you're happy with. And we work with abstractions all the time, right? We don't work with machine code anymore. We don't work with assembly code anymore. We have created higher order abstractions, that high detail that we don't need to engage with, that allow us to spend more of our brain power doing the job, right? And so if we can hide more detail and then just focus our attention on what's important, we'll get more things done. So thinking about this level, I'd really encourage you to say, well, do we need to manage any of this? And like, maybe if we're really, really cautious, maybe just offload your VMs, just try using managed VMs. But I'd encourage you to push yourself a bit further. Just pick one piece of functionality. Maybe pick something you do as part of a test process or a CI process and get that running as a function and learn what that's like. Get a sense of the workflows available to you. Fundamentally, this is kind of sensible, right? You're just offloading work to someone that can do a job better than you can. I have a big garden now. I'm very, very lucky. I left London a while ago. And so I moved out to the country and I've got a big garden. I don't know what to do with the big garden. So I got a gardener to help me. Otherwise, my garden would be dead. So this is what we do all the time. And we go and get people that are smarter at this thing than we are, that can do a better job more effectively. And I don't think this should be any different when it comes to our infrastructure. And ultimately, I don't think you're really going to get a handle on this until you try it. And with that in mind, I want to one last caveat, which is that I think FAS is the future of how most people will be deploying software in the future, some version of FAS. I think what we're seeing right now is the first generation of that abstraction, but as an abstraction, as a primitive for deployment management, I think FAS is really excellent as a concept. Some of the current implementations have some really annoying limitations, right? They're not anywhere near as good as they could be. But I think a large amount of our workloads could be run on these things. So the quality of the user experience around some of these things is not as good as it could be. There are some things that people are now using to run, a lot of people are using sort of third-party SDKs to kind of, sort of try and deal with some of the rough edges around these solutions. One of the ones that I quite like is the serverless framework, which is an annoyingly named thing because it's really mostly about FAS. But anyway, really good SDK. They've got some commercial offerings around it. I don't know how they work. I only really use the open source stuff. You get a lovely CLI for working with functions on either Azure or AWS. I haven't used their stuff on top of OpenFAS or Google. But this can work really, really nicely. So give it a go. Try spinning up a function, see what happens.